Okay, so now that we solve for the value of y, we can substitute this to the value on the variables on the variables of the height and the radius. Okay, so the height is equal to 5y plus 9, and we can simply substitute the value of y, which is 3.44 to 5y plus 9, and we can also do that for 2y minus 3. Okay, so that will be 3.44 times 2 minus 3, so that will be 3.88. So 3.88, this is going to be our radius and centimeters. Okay, so 3.88 centimeters, and then to find the height, that's 5 times 3.44 plus 9, so you're going to get 26.2 centimeters. Okay, so we have the radius and the height. Now we substitute these two values to the formula for finding the surface area of a cone, because that's one of the problems that we have here. We want to know the surface area of the cone. Okay, to solve this, we have to simply substitute r and h. So that's going to be pi times r. So it's r 3.88. Then you have to square that, and then plus pi times r, which is 3.88. Okay, so that's kind of like also 3.88 pi multiplied by the square root of h squared, which is 26.2 squared. And what's 26.2 squared? That's 686.44. So 686.44. And then we have 3.88 squared. Okay, 3.88 squared, which is 15.05 plus 15.05. And from here we can compute that the value of the surface area of the cone in centimeters squared is, so the value is 370.14 centimeters squared. Okay, so this is the entire surface area of the cone that we have for our problem here. And we also solve for the radius and the height and the value of y. Okay, so for our fifth problem, we have here a pyramid. Dr. Geronimo wants to build a pyramid-shaped roof on her Nipa hut-inspired villa. The dimensions of the said pyramidal roof is shown on the image on the left. The area of the base, the base is 100 meters squared, and the base of the pyramid is a rectangle. So find the value of b, the slant height, the pyramid, its length and width of the base, and the surface area and the volume of the pyramid. Okay, so there are a lot of things that we need to find for this problem. But the first thing that we can do is we can try to find the value for d. Okay, so to solve for the value of d, you can see that the area here is 100 meters squared, and that's the base area. And we're also given that the length and the width, okay, is equal to 3d plus 9 and 4d minus 1. Okay, so if the base area is equal to the length times width, okay, so that's how we get the base area, and the length times width is equal to 100, therefore we can equate these two algebraic expressions. So we have here the length times width will be 3d plus 9 multiplied by the width, which is 4d minus 1, is equal to 100. Okay, and from here we can now solve for the value of d by simply multiplying the binomials that we have. So that will be 12d squared, okay, plus 33d minus 9 is equal to 100. Okay, and from here we can transfer the 100 to the other side. That's going to be 12d squared plus 33d, okay, plus 91 is equal to 0. And from here we can solve for the value of d using again our scientific calculator, or Casio scientific calculator, or other scientific calculators that you may have, using again these steps that I taught you guys. Okay, so we have here the formula 12d squared plus 33d minus 109 is equal to 0. Okay, so if we transfer 100, that will be negative 109, and d will be equal to, okay, so the value of d, if you use your scientific calculator for computing for the quadratic equation that we have here, will be equal to, okay, 1.94 and negative 4.69. And since we cannot have a negative root again for our variables, then we're going to have to use 1.94 as the value for d. So after having solved for the value of d, so d is equal to 1.94, we can substitute that to the values of the width and the length okay, width and the length of the base, okay, so that's 3d plus 9 and 4d minus 1 respectively. So d is equal to 1.94, so we substitute 3 times 1.94 plus 9, you get 14.82 meters. And for the length, you have 4 times 1.94, so that's 4 times 1.94, that will be 7.76 minus 1, that will give you 6.76 meters. And now we need to solve for the slant height and the height of the pyramid itself. Okay, so that will be 6L, so this is the slant height there, and the height itself of the pyramid is 2 width. Okay, so we multiplied the length, okay, so 6 times the length, which is 6.76, we will get the slant height, and then that will be 2 times the width for the height or the altitude of the pyramid itself, which is 14.82. Okay, so 6 times 6.76, okay, so that will give you 40.56 meters. So this is the slant height of the pyramid, and then 2 times, okay, 14.82. Okay, so this is the height of the pyramid itself, which is 29.64 meters. Okay, so to solve for the surface area of the pyramid, we use the formula the lateral surface area plus the base area. So the lateral surface area are the four triangular faces of the pyramid, and the base area is the base. Okay, so the area of the base of the quadrilateral base. Okay, so we have here the formula for the lateral surface area is 1/2 the perimeter of the base. Okay, 1/2 the perimeter of the base times the slant height plus the base area, which is length times width. So how do we get the perimeter of the base area? This is the one that's missing. Okay, since we know that the base of the pyramid is a rectangle, we can use the formula for finding the perimeter of a rectangle to solve for the perimeter of the base of the pyramid. So that's 2 times 6.96 the length plus 2 times 14.82 the width, which will give you 43.16 as the perimeter of the base. And then we can simply substitute that. So that's 1/2 43.16 times the slant height. Okay, so we already solved for the slant height, which is 40.56. Okay, so times 40.56 and then plus the length and the width. Okay, so the product of the length and the width, so that will be 14.82 times 6.76. And from this formula, we can now get the value of the surface area of the pyramid, and that will be equal to 975.28 meters squared. So this is the surface area of the pyramid. Now we just need to solve for the volume. Okay, so how do we solve for the volume? Okay, again, so the formula for the volume is 1/3 length times width times height. And we already know the value of the length times width times height. That's okay, so the values of the length and the width and the height that we have here a while ago. Okay, so they're given. Okay, so the length is equal to 6.76 meters, the width is 14.82 meters, and the height is 29.62 meters. So if we multiply this 3 and then times 1/3 or divide that by 3, you will get that the volume of the pyramid of the pyramidal shaped roof is, the volume is 989.81 cubic meters. Okay, so we solve for the volume, we solve for the value of d, we solve for the surface area, and we also solve for the 4 values here: the width, the length, the slant height, and the height. Okay, so next we have a parallel pipe problem, solid figure problem. We need to find the volume and the surface area. Okay, so Nash received a regular parallel pipe shaped holiday gift. So it's given here on the image. So the dimensions of the GIF are shown on the illustration on the right. The volume of the regular parallelopipe is 920 cubic centimeters. So find the value of x, the length and the width of the regular parallelogram. Okay, so that means all of the parallelogram faces here are the same, and the surface area of the regular parallelopipe. Okay, so we're given here the volume. Okay, so the volume is equal to 920. And we all know that the formula for the volume of a parallelopipe is the area of the base, okay, times the height, okay, or the altitude of the entire parallelopipe here. Okay, so this is the altitude of the entire parallelopipe. So we first want to know the value of the area. Okay, so in order for us to solve for the value of the area, we need to substitute some values. Okay, so V is equal to 920 is equal to, so the area of the base, okay, the area of the base is equal to the length times the width. So this is just going to be x minus 1. Okay, so this is the base times x plus 3. And then we also have here the height. Okay, so the height of the pyramid given on, the height of the parallelopipe given on the figure is x plus 3 also. Okay, so we have here a cubic equation. Okay, so we're going to have a cubic equation when we solve this, and if we multiply these three values all together, the answer will be equal to, okay, that will be equal to x cubed plus 5x squared plus 3x minus 9. And then we transfer the 920 on the other side, so we're going to get x cubed plus 5x squared, okay, plus 3x, okay, minus 929, okay, and then that will be all equal to 0. And from here we can get the roots, okay, the cubic roots. So that means there's going to be three roots for this problem, and they are, using the calculator, okay, so they're going to be x, the first root is going to be 8.26 using the Casio scientific calculator, and the third root will be negative 0.63 plus or minus 8.18 times I. Okay, so this is an imaginary number, and this entirety is a complex number or complex root. So we cannot have a complex root as our root here. So the value, the first root is going to be our value for x, okay, which is 8.26. Okay, so we substitute that value here. Okay, so x is equal to 8.26. Okay, so now that we have the value of x is equal to 8.26, we can substitute this to the missing values of the length, the width, and the height. Okay, so since the width and the height are the same, they're x plus 3, so we did that, and then the length is equal to x minus 1. And 8.26 minus 1, that will give you 7.26 centimeters as the length, and 8.26 plus 3, that will give you 11.26 centimeters. That will be the width and the height, okay? That will be the width and the height of the parallelopipe. So to solve for the surface area of the parallelopipe, we have this formula, the lateral surface area plus the base area. Now we have 4 parallelograms here as our lateral surface area, and 2 parallelograms as our base area. So we simply multiply 4 times the length and the width, so that will be 7.26, okay, times 11.26, and then we add that to, okay, plus 2 times 7.26 times 11.26, okay, and from here you can get like 6 over 6 times 7.26 plus 6 times 7.26 times 11.26, and the value of that, okay, so the surface area is equal to, okay, so the surface area is equal to 490.49 centimeters squared. So this is the surface area of the parallelopipe figure that we have here, and this is the, okay, this is the surface area, and we also solve for the value of x, 8.26. And we also solve for the value of the length, the width, and the height here, 7.26 centimeters and 11.26 centimeters.